They're very near the edge of the bubble the sun creates around itself called the heliosphere. We're getting very close to the boundary. We don't know how close because no spacecraft has ever been there before. But it could be another few months, it could be another few years, but it's probably not much longer than that. We travel 1 billion miles every 3 years.
Humanity has always been fascinated by the sky above us and everything it has. Curiosity is one of humanity's strengths and will continue to be a prominent trait. Countless people have wondered what is beyond our world, and their inquiries have led to new discoveries about the universe. The universe is vast and complex, and since the advent of space exploration technology, human beings have been eager to learn more and more about its mysteries. We know very little about it, but humanity is anxious to unravel its greatest secrets. Many missions, like as the National Aeronautics and Space Administration's Voyager, have been carried out to increase our understanding of the cosmos. The Voyager missions have played a crucial role in space exploration for almost 45 years, providing the first significant glimpses into the true state of our solar system. However, if the stars had not aligned, two of the most remarkable spacecrafts ever launched would never have launched. The stars in this scenario were actually planets, the 4 largest in the solar system. 45 years later, both probes are still traveling across interstellar space. Researchers, some of whom are younger than the spacecraft, are actively exploiting Voyager data to solve riddles within and beyond our solar system. And recently Voyager 1 came across something unusual. What is this most recent discovery? What challenges will these spacecraft face in the coming years? NASA's twin Voyager probes, launched in 1977, dazzled the world with historic journeys to Jupiter, Saturn, Uranus, and Neptune. Some 60 years ago, these planets were slowly wheeling into an arrangement that had last occurred during Thomas Jefferson's presidency in the early years of the 19th century. For a while, the rare planetary set piece went mostly unnoticed. Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology, was the first to draw attention to it. It was 1965, and the space age was just getting started. The Soviet Union had launched Sputnik, the first artificial satellite. Only 8 years before, Flandreau, who was working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, was tasked with determining the most efficient way to send a space probe to Jupiter, or possibly Saturn, Uranus, or Neptune. He charted the orbital paths of those giant planets with a pencil, a favorite precision tool of 20th century engineers, and discovered something intriguing. In the late 1970s and early 1980s, all 4 would be strung like pearls on a celestial necklace in a long arc with Earth. As pioneering interstellar probes more than 14 billion miles from Earth, they are currently startling physicists with a variety of unexpected discoveries concerning that unexplored region. Finally, their incredible journey is drawing to an end. NASA has shut off heaters and other non-essential components during the last 3 years in order to extend the spacecraft's energy supplies as far as possible to 2030, which is the predicted end date. It's a bittersweet occasion for the scientists working with the Voyagers, many of whom have been with the mission since its inception. They are now faced with completing a project that exceeds their wildest expectations. Returning to Jupiter, the spacecraft began transmitting the first photographs of the planet despite being 3 to 4 months distant. It was completely unexpected for Io to appear in color. Prior to the Voyager expeditions, it was assumed that all moons in the solar system would seem the same, dull and cratered. The extraordinary variety of moonscapes that the Voyagers discovered in the vicinity of Jupiter and Saturn was not anticipated. The cameras on board the Voyagers revealed that Io has active volcanoes. The little world, which is slightly larger than the Earth's moon, is now known to be the most volcanically active body in the solar system. The components spewed by the moon's volcanoes are responsible for the colors of Io. Pele, the most powerful of Io's volcanoes, has emitted plumes 30 times the height of Mount Everest, and its ash. But what was the latest signal? NASA revealed in 2013 that Voyager 1 had crossed the boundary separating our solar system from interstellar space, which begins where the sun's continual flow of particles and magnetic fields cease. Voyager 2 eventually entered interstellar space in 2018, becoming the only spacecraft that has explored interstellar space so far. The two spacecraft investigated how the interstellar medium interacts with solar wind, the sun's continual flow of charged particles. They have also supplied information about the heliosphere, a protective bubble that surrounds our solar system. The actual border of the solar system, where solar wind ends and interstellar space begins, is called the heliopause. The Voyager spacecraft has supplied fresh knowledge about interstellar space, discovering that cosmic rays are approximately 3 times more intense beyond the heliopause than deep within the heliosphere. The interstellar medium, like the ocean, is full of turbulent waves. The largest are caused by the rotation of our Milky Way galaxy, as space smears against itself, creating undulations tens of light years across. Smaller ripples rush from supernova explosions, spanning billions of kilometers from crest to crest. The smallest waves are usually caused by our Sun, as solar eruptions send shockwaves through space that permeate the lining of our heliosphere. These crashing waves reveal information about the density of the interstellar medium, which influences our understanding of the shape of our heliosphere, how stars form, and even our own position in the galaxy. The plasma wave system on Voyager 1, which includes 2 antennas protruding 10 meters behind the spacecraft, was designed to detect that ringing. It's very faint and monotone, because it is in a narrow frequency bandwidth, said Stella Koch-Ocker, a Ph.D. student in the Department of Astronomy and the Cornell Center for Astrophysics and Planetary Science at Cornell University. We're detecting the faint, persistent hum of interstellar gas. This enables scientists to better understand how the interstellar medium interacts with solar wind, as well as how the interstellar environment shapes and modifies the solar system's heliosphere. 3 months after leaving the heliosphere, Voyager 1 heard interstellar sounds for the first time in November 2012. 6 months later, there was another whistle, this time louder and higher in pitch. The interstellar medium appeared to be getting thicker, and quickly. They've only been seen about once a year, so relying on these kinds of fortuitous events meant that our map of the density of interstellar space was kind of sparse. Dr. Ocker explained. Dr. Ocker and colleagues set out to fill in the gaps with a running measure of interstellar medium density that does not rely on shockwaves propagating out from the Sun. They discovered a promising candidate after filtering through the Voyager 1 data, looking for weak but consistent signals. Scientists merged Voyager findings with data from subsequent missions to obtain a more complete picture of our Sun and how the heliosphere interacts with interstellar space. Last year, scientists announced that Voyager 1 had recorded a humming noise that was linked to waves identified in minuscule amounts of gas found in the near emptiness of interstellar space. Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., stated that the Voyagers had supplied significant information about the Sun and its influence throughout the solar system. The Voyagers have changed our understanding of the Sun and its influence in ways that no other spacecraft has been able to achieve. Each Voyager is powered by a plutonium-based thermoelectric power system. As the plutonium breaks down, heat production decreases, and the Voyagers lose power. To compensate, the NASA team turned off all non-essential and several originally considered necessary systems, including heaters that safeguard still operational instruments from the intense cold of space. However, all 5 instruments have had their heaters turned off since 2019 and are still operational. NASA experts are still puzzled as to how the Voyagers can continue to operate in temperatures well below what they were built for. Scientists have also detected something strange going on in the solar system's outskirts. The heliopause, which is the barrier between the heliosphere and the interstellar medium, appears to be rippling and creating oblique angles in an unexpected way. While the general concept that the heliopause changes shape is not new over the past decade, researchers have determined that it is not static. They made this discovery using data from the only 2 spacecraft to leave the heliosphere thus far, Voyager 1 and Voyager 2, as well as NASA's Interstellar Boundary Explorer, IBEX, satellite, which studies the emissions of energetic neutral atoms, ENAs, produced when solar winds and the interstellar medium interact. The Voyager spacecraft provide the only direct in-situ measurements of the locations of these boundaries, but only at one point in space and time. The new signal is known as plasma wave emission, and it appears to track the density of interstellar medium. The tone of the emission rises and falls with the appearance of the abrupt whistles in the data. The signal is also similar to one observed in Earth's upper atmosphere, which is known to track with electron density. It is anticipated that the spacecraft will eventually leave these turbulent shores behind and come into contact with something new in the interstellar space. The Voyagers have lasted longer and traveled farther than any other spacecraft in history. They are the first objects created by humans to enter interstellar space, and they will remain so for at least another few decades. Overall, not a bad record considering the Voyager missions were only supposed to last 5 years. Voyager 1 will pass by Proxima Centauri, our nearest neighbor star, in 16,000 years, while Voyager 2 will take 20,000 years. They will then spend millions of years orbiting the galaxy, long after our sun has died. Let us know what you think about the Voyagers in the comments section below. As always, thanks for watching our video. See you in the next one.